I tried to be cool, and it didn't work. Matrices. So let's talk about them. What a matrix is basically a way of collecting data.
Oh, this is so.
You vaguely remember this stuff now.
Yeah, from like.
I
Yeah.
remember right now.
And that's what it does. They take a little bit of time to go through. Yes, sir.
Wasn't there a Matrix in one of the Transformer movies?
I don't know.
Don't you have to like add in some fact?
Yeah, we're gonna do some very simplistic stuff. What I want to do today is kind of define what a matrix is, talk about what's called their dimension, talk about how you identify them, how you label them, and how you do some simple arithmetic with them. Today isn't going to be all that bad. When you're dealing with a matrix is always denoted by columns, or the brackets, excuse me. And then inside the brackets, you will see rows and columns. When you define a matrix, you define it by its capital letter. They give it a capital A. And then when you define it by its dimensions, you say it in terms of rows and columns. In this case here, there are 2 rows. Remember, you row a boat, going across. Row, 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 your boat. And columns hold things up. So this goes rows by column. It's a 2 by 3 matrix. Okay. It has 2 rows and 3 columns. That's one of the things a lot of people, to start out with, kind of forget how you label them. Rows by columns. Rows by columns. Okay. The values that are inside those rows and columns, these numbers, these guys are all just called entries. They're just called entries. As we get into this chapter further, you will find out that we can basically do all of chapter 3 with matrices. And you will find out that we can use their coefficients of of variables as your entries. And we'll get to that. So if you have a 2 by 3 matrix, that is what's called its dimension. And in order to do any adding or subtracting with matrices, they have to have the same dimension. Also, I do want to kind of show you a couple other definitions. You don't have to write these definitions down, but I just want to show you in case you hear the term. That way you kind of get an idea of what things look like. Remember, rows, columns. Row, row.
That's so trippy. Oh, it's not.
You're not impressed. This is your not impressed face. I can see that. Row matrix, very simple. It's a matrix with just 1 row. Column matrix, matrix with 1 column. You have a square matrix. We deal a lot with these. Yeah, Reggie? No, don't write these down.
Oh.
I already said that. I said don't worry. I just wanted to define a few things so you can see what they look like. Before you gave me the I'm not interested face.
No.
The square matrix. We use square matrices quite often. Square matrix is nothing more than like a 2 by 2, 3 by 3, 4 by 4. The number of rows and columns are equal. That's what they call a square matrix. When we get into 0 matrices, don't see them that often, but one type of matrix that's not up there that we will use a lot in 4, 5 maybe, it's called the identity. The identity matrix will allow us to solve for lots of stuff. Okay. And as I said, in order to be able to do any of these adding or subtracting, the dimensions of the matrices have to be equal. Yeah. This would be. For example, if I'm looking at part A here, I have is that a 1 by 3 or a 3 by 1 matrix?
No.
3 by 1.
It's 3 by 1. That's a 3 by 1. It's 3 rows, 1 column. It's a 3 by 1. And what's the other one?
3 by 1.
Are they both the same dimension?
Yes.
Yes. So that means I can add these 2 guys together. Yeah.
I thought we always like X then Y. Why are we not?
Matrices are a little bit different.
This is X and Y.
You're talking the X's are horizontal, Y's are your vertical.
Yeah.
So it still is, but
it's just like flip them around.
kinda. Don't overthink. Just remember rows and columns. Row, row, row your boat gently down the stream.
Stream.
Are those dimensions the same?
Yes.
Now here comes the real difficult math part.
Is this difficult? Isn't it just
3 plus 1.
4?
Negative 4 plus 0.
Negative 4.
7 plus 3.
10.
Wow. What you do is you match up the corresponding entries, and you do the operation. Yes, sir?
Like, what does your answer mean? 4, negative 4, 10 in a row? Or in a column?
Yeah.
What does it mean?
We're getting there. Right now, today what we're working on is how do you do the operations. Towards the end of tomorrow, you will be solving systems of linear equations via matrices, and you will see how this stuff interrelates.
That's kind of
This is another way of solving systems via not doing the substitution or elimination methods.
So basically, what that
Yeah. Yes, sir.
So this is like squaring numbers, except if you don't want to do it by the same number, you do it by different numbers. So they're all just different equations, but you're just putting them into one. Isn't that what you're
I
doing?
know where you're going, yes, because we are looking at different equations as you go through things here. Yes, we are combining things. Okay. In part B here, are those both 2 by 2 square matrices?
Yeah.
So that means all I have to worry about when I'm adding together, 8 minus 2, 3 minus negative 7,
10.
4 minus 6, and 0 minus negative 1. The mistake you're going to be making is when you'll flip-flop a value or you miss a negative. Yes, sir?
Are there going to be word problems with this?
Yes, we'll get to that. We'll get to those. The word problems with this style are easier than what the old ones were. We could solve all the old word problems pretty easily with matrices.
And why did you
Because I'm a jerk. You gotta go the long way around.
use it? Are these people going to make money on these words?
And in the last part there, can I add those two together?
No.
No, they're not at the same dimension. So basically, if that occurs, you just put the empty set, no solution into that setup. This won't work. No can do.
That's it.
Or that. Okay.
Definitely.
All right. You can't because they don't have the same. They don't have the same value. They don't have the same entries there, or the same dimensions. Excuse me. Now, what you are also able to do is use what's called scalar multiplication. Now, when I'm looking at the scalar multiplication within matrices, is nothing more than the distributive property. You're basically distributing the, in this case, that first problem, the 3 to all 4 entries. And the other one, it's an order of operations problem. Please excuse my dear Aunt Sally. In that idea, you have to take care of the multiplication before you add. So if I did that, I'd have to distribute the -2 to everything in this entry before I add it to that one. Dimensions are the same, so it still works. So what we're looking at here today is just order of ops, add, subtract, multiply. Okay? So this new matrix here would be -6, 0, 12, and then -21. All I'm doing is multiplying everything within the matrix by 3. Okay? Think of it as just plain old distribution. It works the same. Your distribution properties, your commutative properties, they all work the same within matrices. One thing that is a little bit different is when we do multiply matrices together. There is a real big important thing that occurs, and we'll get to that here in a few minutes. In that second problem here, again, we're doing nothing more than setting up an order of ops problem. And in this case, the order of operations is telling me that I have to do what first? Multiply that first matrix by -2. And one of the things I'll suggest if you're doing these types of problems out of your book, don't write the whole thing out. It's a lot of writing, a lot of numbers. Just do the first operation and write it out as -2, 4, 0, -6, 8, -10. And to that, you know you have to add them here and here and so on, right? So just do that. -2, -4, 4, 5. 0, 6, -6, -8, 8, -2, -10, 6. And there's my answer. You don't have to write down every step. I don't expect you to. I hope you know. Yeah.
I have a cheesy math joke. But
All right.
after-
No, go ahead. You're probably dying. You'll forget it.
No, it's after. Oh, was that the joke? No. Richie has one that he wants to share. I don't have.
No, mine's not a joke, it's just an alternate line dots. You don't want to hear it.
I don't want to hear it.
I
Here.
wanna hear
Now to the fun stuff. Solve the equations. take a second to write this one out. And what I'm doing here today is starting with one that's probably about as complicated as you're going to see. That way, you see the toughest thing out there, and we work our way to the easy stuff. Makes life nicer. What we have here is 2 times the quantity, one matrix plus one matrix, equals some other matrix.
What does the dy mean?
It was a whole string of words. It said solve for x and y. It just got cut off.
Oh, okay.
So you add it.
I'm gonna write this.
Yeah, because that's your order of operations. So take a second to write that out, then I'll walk you through. Like I said, this is about as crazy as this stuff looks. After this, everything is all downhill.
As in,
As in like downhill in our lives.
Yeah, usually downhill means like bad, like.
No.
No, it's
No,
all down, if you're going down, yeah, exactly.
You don't want
If we're sledding, isn't going downhill fun and happy? A little scary, but fun.
Well,
Oh,
what if you're like
parentheses are first.
falling down
It's
a
like
hill?
your house.
Now, if you were an optimist, you wouldn't be worried about that. You're being pessimistic, not optimistic. Glass half full, glass half empty.
Yeah, I know what you're saying, but I don't know what they're saying.
Optimistic, you're a very upbeat, outgoing, happy person. Pessimistic, you're like, everybody sucks.
Should they like have it or something?
So you're optimistic. Yes, sir.
For like 3x plus 4, you just leave it. Like you leave
Oh,
3x
we're
plus 4.
Yeah. Does everybody have this written down? All right. So let me show you what happens here. If you're talking about solving an equation like this, you always start kind of, can you group anything together? Now, within the parentheses, you can combine those 2 matrices. They're both 2 by 2. Does everybody agree? All right. So if I start with that and I put my 2 out here, I get 3x plus 4. -1 plus 1. 8 plus -2. Oops. 5 plus -y. And I get the resulting matrix for the equation on the left. Do you agree?
Yeah.
Does anything change what's on the right? Nope. Nope. It still has to equal 26, 0, 12, and 8. Now, in order for the 2 matrices to be equal, that means all of their entries have to be equal. So now it's nothing more than the following. This is a scalar multiplication. Do you agree?
Well, what does
It means I'm multiplying everything by that scale of 2.
Oh.
Okay? So that means that each one of these entries has to be 2 times that, right? So I get the following. 2 times 3x plus 4. What does that have to equal on the right? 26. 2 times 6 equals what? 2 times 0 is? So that means that 2 times 5 minus y has to equal how much? And there's your 2 equations you have to wind up solving. Okay.
If you move the scale of those 2, if you just leave them all and then divide everything on the right side,
Absolutely. Yep, that's fine. That's a perfectly legitimate. And what he's saying here is, you notice how you've got the 2 on the left side of the equation? If you divide both sides by 2, it goes away, right? You think of it, it works the same as 2x equals y. X is 1/2 y. That property works by moving that multiplication property back and forth. So if you wanted to do that, get 3x plus 4 equals 13. Isn't that what I'm going to do right here anyway? You can do that. And people have asked me, and that's perfectly fine. If you don't want to do that, it's not a big deal. It's just that it's one extra step. So now you have 3x plus 4 is 13. X is 3. Over there, 5 minus what times 2 is 8? 1.
This is hard.
Yeah.
So check.
No. Okay. Is everybody okay with it just being equal to 1, or do you want me to work that out?
Wait,
Y equals 1?
I don't know what I did. R&D.
Stupid math. Like I said, this is not as crazy as this stuff looks. You've got a scalar, you've got two matrices put together. It's just a matter of piecing it back together into a matrix equals a matrix. And then your entries are the same. Okay? So,
Dang, we already mastered 4.1.
Yeah.
Hashtag accomplished.
Mommy?
what's wrong with this?
You know what it is?
Very good. 4.2. Like I said, what we're doing today, we're talking about multiplying matrices. We have to have one rule to follow. And that one rule is the following. When you have rows by columns in matrix A and rows by columns in matrix B, in order to multiply two matrices together, they write it like this. Matrix A times matrix B. In order for that to work, the number of columns in matrix A has to equal the number of rows in matrix B. If it doesn't, you can't do it.
Okay.
Yes, sir.
So only the columns, the rows, not
Yes.
not the A row and the B column.
Nope. That means something else, and I'll talk to you about that in a second. For example, if I have the following. Thank you, sir.
Thank you.
If I have the following. If matrix A is 2 by 3, and matrix B is 3 by 4,
That's okay.
do their columns and rows match
Oh,
up?
no, can't do that.
Careful. Does the columns of matrix A equal the rows of matrix B?
Yes.
That's weird. Wait, but
Yes.
How does that, time out, how can that work?
Can you, like, show
But
us
adding
the
doesn't.
Yeah, can you
I'm getting there.
why?
I'm getting there.
Wait,
All-
for adding doesn't have to be the exact same. Like
Adding, subtracting, identical.
exact same. Yeah.
Multiplying doesn't, the only rule you have to worry, the only rule it has to be, the number of columns in the first matrix has to equal the number of the rows in the second. The resulting matrix has a different dimension then.
So this way.
It is a 2 by 4.
Wait, what?
Oh. Wait, so what if they're both 2 by 3? That's not.
If they're both 2 by 3s,
That's not good.
once again, if it's 2 by 3 matrix and a 2 by 3 matrix, does the number of rows equal the number of columns?
No.
You cannot do that.
So they're square.
But if they're square, if you have a 3 by 3 and a 3 by 3, do the number of rows equal the number of columns? Yes. You can multiply those together, and the result matrix would be a 3 by 3.
Oh, okay, so, when you multiply the 2 by 3 by the 3 by 4, then
You-
your new
Will be 2.
matrix is 2 by 4.
Exactly.
Okay.
That's exactly what I'm getting at. So when you're setting up these matrices, the only rule you have to follow is that the number of columns in the first one has to equal, that has to equal. If it doesn't equal, you can't do it. If they are equal, then the result, that is the new. Okay? That's the only rule there is with these things. Today, what we're going to work on, though, will always be just square matrices, 2 by 2s. I'm not even going to get into 3 by 3s yet. All right? So what happens here is that when you have a 2 by 2 times another 2 by 2, do those columns match up with the rows?
Yeah.
So the columns match up to the rows, that's equal. So the new one is going to have 2 rows and 2 columns, right? Now, when I go to multiply these things out, we have to start with, well, we got to start with matrices, right? Let's look at 2 matrices. Let's start with this. Let's start with these 2 matrices right here. And I'm multiplying them. Notice how there's no operation between the 2 matrices, they're just put together. Whenever you see that, that is implying multiplication. Okay? Yeah.
You
Okay.
just imply same spot and multiply the
No. Here's where the pattern evolves.
Oh.
The multiplication of matrices is a little bit different than anything else. And I've kind of, over the years of doing this, instead of telling you guys, take the row, multiply it by the column, take the row, multiply it by the column, and go through it, people tend to get lost within it. Okay, and I would stop texting. It's like every other minute. Put it away. I know you're not putting notes down.
No, I wasn't. I promise.
Now, I wouldn't say like the cheater method that I've kind of come up with, it's kind of more of a shortcut way to do these things. And it works. I think that the language that the book goes through with these types of problems is a little muddy. But if you guys see a process and a repeated process, you tend to replicate over time. So I want to show you this process. Do we agree that the result matrix is going to be a 2 by 2? 2 rows, 2 columns? So here's what we do. Once you figure out what the result matrix is going to be, take your first matrix and write it down that many times. I know my result matrix is going to be a 2 by 2. That means it's going to have 2 rows and 2 columns, correct? So I'm going to take this first matrix, 3, 2, negative 1, and 0, and write it down twice. But space it out. Let me show you. 3, 2, negative 1, 0. 3, 2, negative 1, 0. I'm just spacing it out a little bit. Okay? I've replicated the first matrix twice because I know that the new matrix is going to have 2 columns. From there, I follow the other pattern within the columns. What I do is I always start, whether it's a 2 by 2, 3 by 3, 2 by 3, whatever, I always start in the top left entry of the second matrix. In this case, the top left entry is a 1, and I put it as a column. I go to the one below that, the 2. I ran out of that first column. I go to the next column. I have negative 4, and I repeat it. Oops. And then I go to the last entry. It's a pattern. You're taking the first row times the first column. First, second row, second column, and so on. It's a very muddy reason. I meant first column, second entry. If I continue to say first column, second entry, second column, first entry, you can see how it gets muddied through. But if I just show the pattern of first entry goes here, second one here, and so on and so forth, you'll be able to replicate it. Now here's the tricky part. Now I have 4 math problems to do for my 2 by 2.
We have to do that every time we multiply matrices.
Rich, you got a question?
I was just gonna ask you, you just showed.
Okay. Now it becomes really easy. Now that we set it up, what's 3 times 1 plus 2 plus 2 times 2? Excuse me. 7. Negative 1 times 1 plus 0. Negative 12 plus 2. 4 plus 0. And there's your answer. It can be. You can see how a 3 by 3 can get real messy real quick.
Yeah.
You need a little bit of space. You have to have somewhat better handwriting. Or Andrew.
Like, you scroll up with
Sure. Okay. We'll walk through another 2 by 2 here. Or you're right on time. Remember, the trick is, once you identify what your dimensions are between the 2 matrices, when you go to multiply, you always write down that first matrix, the number of columns the answer will have. Okay? So let's look at another one. Remember, today I'm just dealing with 2 by 2s. Tomorrow we'll start mixing it up a little bit. Oh, cursor's in the way there. Sorry about that. Stay right there. What will the result matrix be?
2 by 2.
Okay. I know you guys are still finishing that out, so let me just write this up here. 2 by 2 and a 2 by 2. Do the same. There's my answer. So my answer is going to be a 2 by 2. Once again, how many times do I have to write down the first matrix? Twice. Twice. Let's write down my first matrix twice. And now I start filling in my values. Start at the top left again. And work your way down the columns. And what goes between the sets of 2s? Yeah.
So when you do this, is there even a point of writing that first top left matrix when you we were just doing it out of the book? Would we even have to write the first?
No, just reading the problem right out there. So if you jumped right to the work, that's not a big deal. So now I get the following setup. 6 plus 10. 0 plus negative 15. Negative 24 plus negative 6.
Negative 30.
0 plus 9. Okay. 9?
What does that mean again? Shut up. No, it means no.
You need to know.
In German?
Yeah. Yes.
Can you show us an example of one where they're not squared? It's just a...
We'll get into that more tomorrow. What I want to do today, though, is kind of show you how do you check this. Take out your fancy calculator.
You don't brown.
Oh, we could have done this the entire time on our calculator.
Mr. Murphy, you don't brown swaggin.
Matrix.
Why am I not surprised?
What? There's a matrix button. Imagine that, Alex. Wow.
Yeah, let me just clear this out so I can start over. All right, take your calculator out. There's a button that says second matrix. It's the negative x and the negative 1 button. It's the inverse button. Right, see that? From there, what I want to do is I want to edit. Scroll to the right to edit.
Wait, what? X negative 1 matrix on it. Oh, second matrix.
Yep.
Okay.
Edit, hit enter. Now it says right now matrix A is set up as a 1 by 1. I want to change that to, what did our problem have? 2 by 2. So here's what the great thing is that most students tend to forget what comes first, rows or columns. So let's say you're looking at a 3 by 2 matrix and you're not sure which one is the rows and which one's the columns. If you use your calculator, type in 3 by 2, it'll show you a visual representation of what it looks like. That means you can check yourself to know if you're doing it. So if it doesn't work, then you know you're wrong and you can fix things, okay? So now I know I have a 2 by 2. Now I just go ahead and start entering it in. I'm going to start with my matrix A. I'm going to use that as the first matrix we have there, that 6, negative 2. So, I'm sorry, negative 6, hit enter, negative 2. The calculator automatically scrolls to the right. 0, 3. Once I fill up that matrix, here's where using your calculator becomes a bit of a pain, because you got to press a lot of keystrokes to clear this stuff up. Quit. Second mode. It backs you out. Now you got to go back in. Mode is right next to the second button.
Oh.
Now you got to go back into second matrix again.
And do B.
And do B. So you want to, oops, too many buttons. You want to edit, move down to B.
2 by 2.
2 by 2 again, very good. And then enter in your 2 by 2.
What is it?
Negative 1, 4, negative 5, and 3.
Second.
Yes, sir.
Why do you gotta do the mode thing?
Just to back out of it, so you can go, just so you can go back in. You got to get
Just
out.
press matrix and second matrix again.
Did it drop back in?
Yeah.
Oh, I didn't know that. I didn't know. I've been doing it this way forever. Quit again.
Wait, what can you do instead?
Well, we're about to say it. Now, I need to multiply matrix A times matrix B. So, second matrix A, second matrix B. When your calculator shows those two matrices next to one another like that, it is automatically implying that it is multiplication.
Answer. Same answer, I think.
I hope.
Yes. Wait, which is?
I'll go through again. All
I
right.
think it takes a lot longer on the calculator.
It takes a lot longer. For 2 by 2s, you're going to find out it takes forever on a calculator to type them all in. When you get into larger values, it's a lot quicker, a lot easier. We'll do the one we did earlier.
So, do we get to choose which way we want to do it?
No. I'm going to want you guys to do these things by hand today. When we get to the test and quiz, 2 by 2s you'll be doing by hand. Maybe a 3 by 3 by hand. When we do a lot of the other multiplication, we have to do it in conjunction with other properties. Then it becomes a little bit more calculator dependent. So let's check the other one. We have a 2 by 2 in A, so let's edit it. We already are working with the 2 by 2. We're just going to change the entries. 3, 2, negative 1, 0. All I'm doing is just re-entering into the matrix. I'm going to check our first problem that we did together, make sure we did it right.
Okay.
Oh, it does work. If you hit second matrix, you go right back to the matrix screen. I didn't know you did that. Yeah, sweet. We're going to edit again, matrix B. I just want to fly. I'm going to kind of go through this a little, so I want to get you some problems to try. I can actually do this. We already had it in there, so we got it right. It's math magical.
It's so mathematical. Right?
So the calculator is going to allow you guys to check your homework.
Oh goodness.
Why can't we just do
You
our
are
homework
kidding
like
me.
this?
So we had homework.
This is section 4.1, and this is section 4.2. Those guys are already uploaded on the website as PDF files, and I will have the video up here in the next 10-15 minutes. I gave you the odd numbers for the first section because it's adding, subtracting, scalar multiplication, and a couple of equations to solve for. That way you can check your work to see if you got them right. And then the two in 4.2, those are multiplying 2 by 2s together. I want you to do it by hand. I want you to try that method where I showed you. 2 by 2 means you have 2 columns, write the first matrix twice, fill everything in. Watch your signs. That's where you're going to mess up. Everything else is pretty easy. All right? We'll take it a step further tomorrow. We'll go into a mixture of multiplication. We'll also talk about Kramer's rule. You're going to get really mad at me and I show you how to do stuff a lot easier.
Kramer's rule.
I've already done this like 6 times. There's always an easier way.
Is that like
That doesn't